All right, section 5.3, properties of systems and their solutions. So, warm up, we're going to solve the system, okay, algebraically, okay? So what we're going to do is we notice that this y is all by itself, right? So we're going to take this 3 minus x, and we're going to substitute it in for y up top. We're going to replace that y with 3 minus x, and whenever we substitute, we always want to use parentheses. So we're going to get 2x plus 4 times 3 minus x equals 20. And now we have an equation where there is just one variable in it. So we can distribute and we can solve for that variable. So we're going to distribute the 4 through. We get 2x plus 12 minus 4x equals 20. Okay. Now we want to combine those like terms. We're going to get 2x and negative 4x add up to negative 2x. Okay, and now that we have all of our x's combined on that side, we can subtract 12 from both sides. We get negative 2x equals 8. And then when I divide both sides by a negative 2, get x is equal to a negative 4. So now that we know what x is, we still need to find y, right? So we're going to take that negative 4 and we're going to plug it in to the second equation and we're going to find the value of y. So this one we got to be a little bit careful because when I take a look, we're subtracting a negative 4. Okay, we're subtracting a negative 4. So that's going to turn into 3 plus 4 and we get y to be 7. So our solution is going to be negative 4 positive 7, right? Remember, our solution is a point. So in that situation, right, we just used substitution, right? And we chose substitution because we had a variable that's isolated, so we could take everything on the other side and substitute it in for that variable in the other equation. All right? So now we're going to consider the system shown to the right, and we're going to consider its solution to be 1, 5. Okay, so we're going to show that x equals 1 and y equals 5 is the solution to the system. So that means that we're going to plug in to both of the equations, not just one, both of them, right? We're going to show it's true for both. So 4 times 1 plus 2 times 5 equals 14. We get 4 plus 10 equals 14, and we get 14 equals 14. So it's true for the first one, so that works. And now we're going to plug it into the second one. We got 1 minus a positive 5 equals negative 4. And we get negative 4 equals negative 4. So 1, 5 is a solution to the equation. So now, if it's a solution of both of them, we should be able to find the sum of the two equations, and then we get a new equation, and we're going to see is it still going to be a solution or not. So we're going to take 4x plus 2y, okay, equals 14. I'm going to bring it down here, okay, and we're going to add the two equations together because sum means to add. So we get 5x plus y equals 10, okay, for our new equation. And what we're going to do is we're going to plug in 1 for x, right, and 5 for y, and we're going to see is it still a solution. So take 5 times 1 plus 5 equals 10. We get 5 plus 5, right, equals 10, and we see we get the same thing on both sides. So is it a solution as well, right? Is that new equation still going to give us the 1, 5 as a solution? Yes, it is. Okay, so now we're going to try something else. We're going to try multiplying both sides of the second equation by 2, and we're going to get an equivalent equation. Okay, and we're going to see is that 1, 5 still a solution to this new equation. So we're going to take the second one, right, and we're going to multiply everything on both sides by 2. Okay, so we're going to take x minus y equals a negative 4, and I'm going to multiply everything on the right side by 2 and everything on the left side by 2. Okay, so now when we do that, we're going to get 2x minus 2y, right? Because remember, we're multiplying everything by 2, so we have to distribute that 2, equals a negative 8. And we're going to see, is that point a solution? So 2 times 1 minus 2 times 5 equals negative 8. So here we're going to get 2 minus 10, and we get negative 8 equals negative 8. So is it a solution still? Yes. Okay. So we're going to take the equation that we found in part C, which is this one right here, right, that 2x minus 2y, and we're going to add it to the first equation and see what happens. So our first equation, right, was, remember, 4x plus 2y equals 14. And the new equation was 2x minus 2y equals negative 8. And we're going to add them together, right? And we're going to see we get 6x here, and 2y plus a negative 2y adds up to 0. So those are gone. And all we have left on the right-hand side of our equation is a positive 6. So what happens, right, now we have one variable. Okay, there's only one variable left. So what happens? The y's eliminate each other, right? So the y's are now gone. So we get 6x equals 6, and when we divide by 6, we get x to be a positive 1. So we notice that the y's were eliminated. Okay. And now that we know what the value of x is, right, we can find the value of y, right? We literally are just going to substitute x equals 1 into one of the two equations. And more importantly, one of the two original equations. And then we should be able to find our value of y, right? So if we take 4 times 1 plus 2y equals 14, right? We get 4 plus 2y equals 14. Now we just have a y to solve for, so subtract 4 from both sides. We're going to get 2y equals 10. And then divide both sides by 2, we get y equals 5, which makes sense because that was our value for our solution, right? X being 1 and y being equal to 5. So what does that tell us? Okay, that tells us that we can solve a system using what is called elimination. Okay, first we're going to choose a variable to eliminate. That's the most important thing. I always try and pick the one that we want to get rid of first, right? So choose a variable to eliminate. And then if needed, right, here's a big thing, if needed, multiply one or both equations by an integer to create opposite coefficients, right? So we go back up here, our opposite coefficients were a positive 2x and a positive 2y and a negative 2y, right? So like for example, like we had up above, we had 2y and a negative 2y, right? Because they're going to add up to 0. Okay, so we're going to do that so that we can eliminate one of the variables, and then we're going to add the two equations together to eliminate the variable. Once we do that, solve for the remaining variable, and then substitute in to solve for the second one. Okay, so let's start off with example number 2 here. All right, part A. So we look, right, 4x and 3x are not opposite of each other, right? We need one positive, one negative, and they're not opposite. One's 4x, one's 3x, so if we add them up, they're not going to add up to 0. And negative 3y and a positive 2y, they're opposite of each other, but in this situation, we see that we have a 3 and a 2, right? So they're not going to add up to equal 0. But what we can do is we can go directly to step 2, right? If needed, in this case we do, multiply one or both equations by an integer. Well, when we look at 3y, or a 3 and a 2, the smallest number that they both go into is a 6. Okay, so we're gonna try to eliminate this y. Okay, and we're gonna do that. We're gonna multiply the first equation. I want to turn that into a negative 6. So we're gonna multiply this by 2. Okay, we're gonna get 8x minus 6y equals 30. And the second equation, we want to multiply by 3, because remember our goal is to get rid of the y, so we want to turn that into a positive 6y. Right, so we get 9x plus 6y equals 21. Okay, so when we add these two together, we're going to see that the y's eliminate, and we're going to be left with 17x on the left and 51 on the right. So when we divide both sides by 17, we get x equals 3. Okay, now that we know what x is, right, we solved for the remaining variable. Now we want to do step 5, and we want to substitute into one of our two original equations to find the value of y. Does not matter which one. Okay, so if I take 4 times 3, let's say we plug it into the first one, minus 3y, that still has to equal 15. So we get 12 minus 3y equals 15. If we subtract 12 from both sides, first, we get negative 3y equals a positive 3. Okay, so divide both sides by negative 3, and we get y to be a negative 1. So our solution is 3, negative 1. Now, one thing that I would highly suggest you do is take an extra moment, okay, not going to take long. You don't have to write this out, but always check. Okay, take an extra moment. And we do that by plugging it into the other equation, right? So take 3 times 3 plus 2 times a negative 1, right? We get 9 minus 2, which is 7. Okay, so it doesn't take very long to check your answer, but take that extra moment to check. Just a couple of seconds, plug it into the other equation that you didn't use, right, to check your answer. Okay, so we're going to go to part B now. We're going to try another one. Okay, so here I look at both of my terms, and I see this is a 2x, this is a 6x, so they're not going to add up to 0. 4y and 3y, they're both positive, they're not going to add up to 0. But I do see that in this situation, right, 2x, right, 2 goes into 6, right, 3 times. So we're going to eliminate the x here. Okay, we're going to turn the first equation into a negative 6x. So we're going to multiply this by a negative 3. Everything by negative 3. So we're going to get a negative 6x minus 12y equals 2. And the second equation, we're not going to touch. Remember we said we can multiply one or both of the equations by an integer to create opposite coefficients. So the second one, I am just going to bring down here. We're not going to change anything. And when we add these together, right, our x's are now eliminated. Okay, negative 12 plus 3 is a negative 9, and 2 plus a negative 3. All right, whoops, I forgot to multiply this by 3, see, or negative 3. This should be a negative 6. Okay, when I add those together, we get a negative 9. So divide both sides by negative 9, and we get a positive 1. So y equals a positive 1. Okay, plug it back into one of the two original equations. I'm going to pick the first one, okay, the top one. So 2x plus 4 times 1 equals 2. Okay, we get 2x plus 4 equals 2. We're going to subtract 4 from both sides. We get 2x equals a negative 2. And then when we divide both sides by a positive 2, we get x to be a negative 1. So our solution is negative 1, positive 1. Okay, take that extra moment. Be sure to check it. Don't forget to check. Take that extra moment to check. Plug it in. 6 times negative 1 is negative 6. 3 times 1 is 3. And negative 6 plus 3 is negative 3. So it does work. Okay, that didn't take me very long. Take that extra moment to check it out. All right. When you're done, or right now, you should pause the video. Okay, try to do the lesson check and then unpause the video and check your answer. Okay.